Hey everyone, today we'll be solving LeetCode problem number 1291, sequential digits. This question has been asked in Amazon, Bloomberg and Adobe. In the problem statement, they are saying that an integer has a sequential digits if and only if each digit in the number is one more than the previous one. Okay, so the integer will be called having sequential digit if it is in the form of this 1, 2, 3, 4, 5, 6, 7, 8, and let's say 1, 2, 3, 4 like this. And if it is in the form of this 1 for 1, this is not having sequential digits. Every digit should have a value one more than the previous one. Okay, and what we have to return a sorted list of all the integers in the range from low to high, inclusively that have sequential digits. Okay, so what we will be given is we will be given a value of low and high. Let's say we will be given two integers, low and high, and what we have to return is we have to return a list of integer having numbers which are having sequential digits from this range, low to high. And they are also saying that the constraints will be from 10 to 10 to the power 9. Let's try to explore it further. Here the value of low and high will go from 10 to 10 to the power 9. So minimum value can be 10 and the maximum value can be 10 to the power 9, which is this value. First of all, let's have a look on any example. Let's say value of low is given as 100 and value of high is given as 300. So what should be our answer in this case? We have to return all the numbers having sequential digits. So the first number will that is going to have sequential digit should be 1, 2, 3 after 100. And after that, what is the next minimum number that will be having sequential digits is 2, 3, 4. It's clear to us that starting with 1 we have only one number and starting with 2 we have only one number. And here if we try to move further we can have 3, 4, 5. 3, 4, 5 is going out of bounds, so we are not going to consider that. And these two values we will be having in our answer 1, 2, 3 and 2, 3, 4. So this is going to be our answer result. This list we have to return for these inputs. Okay, now it's clear to us that we will start from low and move till high, and we will check whether every value of n is having sequential digits or not. If that is the case, if we try to go brute force, what is the time we are going to take? We will be taking order of n, and the n value will go from 10 to 10 to the power 9. So in the worst case it is going 10 to the power 9. And how we are going to do that? It's just a simple loop for I equal to low and I less than equal to high. And for every value, let's say 4, 5, 6, we will be checking digits. First digit, the second digit should be one more than previous one, and third digit should be one more than previous one. If that is the case, we are going to include that in our answer, and our answer is definitely going to be in the sorted form as requested in the problem statement. Okay, so brute force is clear to us that it is giving me order of n time. But can we improve it further? Let's start looking at the constraints. We are given that for our input, low value and the high value will go from 10 to 10 to the power 9. Okay, 10, 1, 0. And if I ask you what is the next number after 10 that is having sequential digits, that you can tell me directly that 1, 2 is going to have sequential digits after 10. And what about 10 to the power 9? And what is the maximum number we can have that is less than 10 to the power 9 and having sequential digits? Okay, if I take 10 to the power 9, it will be this. And for a number to have a sequential digits, its value can go from 1 till 9. So maximum value can be 1, 2, 3, 4, 5, 6, 7, 8, 9, which is of length 9. So this number is the maximum number we can get in this range if the high value is greater than this. So it means length 2 is the minimum number and the length 9 is of the maximum sequential number. Okay, so the length will go from 2 to 9. Let's form a table. For any number to be having sequential digits, we can have these many lengths. And for length 2, we already know that it is starting from 1 2. And if I try to get a like a bigger number from that, it should be 2 3, 3 4, 4 5, 5 6, 6 7, 7 8, and 8 9. Only these many number we can have. And for the length 9, you already know 1 2 3 4 5 6 7 8 9. This is the only number we can have. And if I take a length 8, it should be 1 2 3 4 5 6 7 8, and starting with 2. Only these two number we can have. If I try to fill the table, our number can start with 1 and 2, and it can go till this value. So whatever range they will give us, whatever value of low and high we get, our number will be from this list. These are the only candidate we can add to our answer list. So it's a very limited set. And so what we can do is, for every value of low and high, what we can do, we can iterate over our candidates. We can iterate over our candidates and we can see whether it is greater than equal to the low and less than equal to high. If that is the case, we will add I to my list, answer list. Okay, simple. And that is going to be my answer. As we are having very limited candidates, so what is going to be the time complexity here in this case? Time complexity will be order of 1. So for whatever value of low and high I get, I will be able to give the solution in just one iteration of these many times. Or you can say order of 36, because we are having only 36 candidates. So whatever value of low and high we get, we can compare these 36 candidates over these values. So 36 is a constant. So in the order of 1, we are able to solve this problem. And the space is also going to be order of 1. We are storing these values only in a list. Let's try to have a look at the code. Here what I did is, we get only these 36 candidates. That can be our answer for any value of low and high. So what I can do is, I will just check what are all the candidates from this list is falling in under this range. So we can iterate over our possible numbers. I equal to 0, I less than n, and I plus plus n is equal to all possible numbers dot length. So these numbers. So if the possible number is greater than equal to low and less than equal to high, so I'm going to add that in my answer list. So this is my answer list to store the answer, and in the end I can return answer. So every value of low and high, it is going to be running only for 36 time. So it's a constant time solution, and you can also say the constant space. Okay, I hope you understood the code. I will also be attaching this code in the comment section below. Okay, thank you guys.